let's look at another scenario here. Common thing is when multiple forces are acting at a point, common thing is there will be a resultant force. When we actually replace the force with the power, let's suppose we tackle this issue, instead of calling them newtons, we'll call them power and give them an entity, energy entity, and then we see what happens here. There's a F1 force here going up. This is the O is the object, and F2 is F1 is 6 joules per second. This system, whatever the entity that is pulling this object in this upward direction, is expending 6 joules per second in each second, and F2 is 4 joules per second. So when combined activity, combined result of these two forces is there's another force, or that will be, so because this is a rectangle here, the resultant force will be the squares of these two forces, F1 and F2. 6 square root plus 4 square root are equal to 7.21 joules per second. So we can represent resultant force as 7.21 joules per second. When you see here the clear conflict between the total amount of energy being expended in a second and total work being done in the system. When you see total energy is 6 plus 4, 10 joules per second. 6 plus 4. These two forces are doing 10 joules of work in each second. But as a result of these two forces being in a 90-degree angle, the resultant force is doing only 7.21 joules per second. The difference of 2.79 joules per second is basically unaccounted for in this system. So what exactly is happening to the difference energy, the 2.79 joules per second? The differential energy, whatever the difference between the resultant force and then the total force, is actually pulls the object apart. The F1 and F2, when only let's assume only this R force is there on this object, and then it will be pulling in one direction, and that time you won't, whatever the energy you expend, you get that much work. And when multiple forces are working on a point, the point undergoes tremendous amount of stress at the same time. As it displaces from one place to another, the object itself undergoes tremendous amount of stress. Like when you pull an object from two directions, like let's take here scenario, like F1 is 5 joules and F2 is 5 joules per second, and this is the object here. Let's suppose here both the forces are equal. When you pull an object from two directions, 180 degrees, the object doesn't move. So resultant force is 0 joules per second. So, but you are expending a total of 10 joules per second. 5 joules here, 5 joules there. So what exactly is happening? Where the energy is going into? The 10 joules is going in destabilizing the internal structure of the object at the point O. If a weaker object is there at the center and you keep on pulling it, the object will break apart. That's what is exactly going to happen. The difference energy, the 2.79 joules per second, will actually attempt at splitting the object apart. You can't move this object forever, taking 4 joules this way and then 6 joules this way and keep on moving the object. At certain point of time, maybe 10 miles, 20 miles, This 2.79 joules per second in each second builds up and then continuously pull apart the object. So due to that stress, eventually this object will split. So this is what is the true picture of when multiple forces are acting on an object. Force is nothing. It doesn't give us the actual energy transfer in the system. So it basically wraps everything in a way, and it doesn't exactly describe the true picture of the system. When we replace force with the actual true entity power, then we clear picture of what exactly is happening in the system will emerge. So this is why I call force is one of the basic fundamental mistake we are doing in physics. So that covers